Good morning. Today we are going to see modeling cables in EMT software, PSCAD. Study agenda. Required EMT model cable parameters that is getting from datasets and PSCAD coaxial cable parameters. And what is meant by relative permittivity, epsilon r, and what is meant by relative permeability, mu r. So you can see right side the cable structure, which is from coaxial cable structure. Okay. So in center, you can see my cursor. Center this conductor. This conductor can carry currents, you know already. And next one insulation, and next one screen wire, and again insulation, and again armor, and uh, insulation. So these are the coaxial cable structure. Okay. So inner conductor carrying the current and insulation dielectric layer to block leakage and screen and sheath conductive shielding and outer jacket its protective mechanical layer and PSK geometry parameters. What are the parameters we have to enter in the PSK coaxial cable structures? First, we have to enter the conductor diameter radius, conductor radius, and insulation radius, and outer radius. Okay, and electrical properties. The electrical properties means that resistivity, capacitance, and inductance. So these are the inputs you have to give in the coaxial cable, the PSCAD. Now, understanding the relative permittivity. What is mean by relative permittivity? Relative permittivity is nothing but its dielectric constant. Okay, it measures how much electric energy an insulating material can store compared to free space. Okay, higher value means better storage capacity, leading to higher capacitance. Okay, so epsilon r is more than more than one. It that means that having more capacitance, higher capacitance. So higher capacitance can lead to higher charging current and higher reactive power. Okay, in right side you can see the cable parameters which is taken from the PSCAD. In the first insulating and semiconductor, in that can go to electrical properties. In the electrical properties, you can see relative permittivity 4.1 I have mentioned. Okay, so this means epsilon r I can derive from the capacitance. Okay, so that has some formula to calculate this one. Maybe next session I'll show you how to calculate this for relative permittivity. Okay, now come to mathematics of form of epsilon r. Epsilon r is equal to epsilon divided by epsilon naught. Epsilon naught, it is the um, it is the ratio of the permittivity of the material to that of vacuum. Okay, that epsilon naught you can say 8.854 into 10 power minus 12 Faraday per meter. Okay, here epsilon r is no unit, no dimensional, so you can say only value. Next. Epsilon r is equal to 1. Materials behaves like a vacuum or free space. Higher, already we discussed, epsilon r higher means that more electrical field or more higher capacitance. In cables, it affects higher charging current and reactive power generations. Okay, and now what's mean by relative permeability? Okay, understanding relative permeability, mu r. Uh, measures how easily material allows magnetic flux to pass through it compared to vacuum. So you can say this as inductance, it's replicated in the relative permeability. Okay, okay, you can see the mu r formula, mu divided by mu naught. Mu naught here it is 4 pi into 10 power minus 7 Henry per meter. Okay, so mu r, there are three different classification for there. Mu r is equal to 1 means that is copper or aluminum conductor we are using in no, well, in electrical field we are using copper and aluminum. So mu r is 1, always is 1. In a PSCAD also you can use it mu as a 1. Okay, and summary of cable modeling. You have to get the parameter for the conductors, insulations, and resistivity and capacitance, and those values you can get it from the data sheet. Okay, and from that you can calculate dielectric properties epsilon r. Okay, this can be represented from the capacitance and mu r from the inductance. Okay, thank you all.